The next functional group that we're going to study is the alcohols. And yes, alcohol, you've heard of the word alcohol before, sure, being teenagers and the destructive consequences of too much of this particular functional group. An oxygen-hydrogen group. Oxygen-hydrogen group. Covalently bonded to a carbon atom. Okay, and that, don't worry about the covalence, like where's the ionic bond, don't know. Just worry about oxygen-hydrogen group, that's the OH group. It's right here in this diagram. It's called a hydroxyl group. So whenever you hear the functional group of the hydroxyl group, that's the alcohol. So hydro from hydrogen, oxyl, oxygen. Okay, hydroxyl group. An organic compound in which a hydroxyl group replaces a hydrogen atom of a hydrocarbon is called an alcohol. So, as you see here, this is the methane molecule, CH4. This is an alkane, as we know from previous classes. That's an alkane. All single bonds. It's an ane, carbon, hydrogen, hydrocarbon. If an alcohol group comes in and replaces one of the hydrogen to form this particular molecule, now it's something different. It is of the category, the alcohol, because it has a hydroxyl group on it. Now we're going to talk a little bit about naming very soon, but methane now becomes methanol. Okay? Alcohol, methanol. Now why would it be methanol? Because there's only one carbon. Alright? So this is the simplest alcohol, one carbon, with the alcohol group on there, and it's called methanol. Remember the R's here. R is some carbon or carbon chain, and so ROH would be the general formula for an alcohol. Sometimes you'll see it like this, R-OH. Alright, naming alcohols. When we name them, as you saw in the previous slide, there's an ending or a suffix that is OL, all. So when naming a simple alcohol based on an alkane chain, the IUPAC rules, which we haven't really talked much about this, but all of the rules that we're talking about when we name these organic compounds, they come from a universal sort of system of rules that's set up that everybody follows. It's called the IUPAC rules. International Union of Pure and Applied Chemistry, I believe is what that stands for. Rules. So IUPAC, International Union of Pure and Applied Chemistry. And these are the rules that we're following. So you can look these rules up, and they're online and in your textbooks. Okay, so again, we have another simple alcohol here. And you may, if you drive a car, if you've ever filled up the gas tanks, you may, ethanol blend, right? Fuel. There's ethanol in fuel. So this is the structure for ethanol. And now that you know about these rules and about how we name things, you can see that F means two carbons. 1, 2. Ethane, okay, so that's an. The A is single bonds there. And the OL means there's an alcohol group that has replaced one of the hydrogens. So you put this all together, here's the structure, and there's the name. You also would see something like this. This is cyclo, because it's in a circle, right? And of course, there's no carbons listed, but when you see this structure, any kind of triangle or square or pentagon or anything like that, that's a carbon ring. Okay? And onto the carbon ring has replaced one of the hydrogens is the hydroxyl group. So this is named cyclohexanol. Cyclohexanol. And of course, you probably understand as we move to this next point here that if the carbon chain gets longer than 1 or 2 carbons, the alcohol group could be on different carbons, making them different isomers. And so, when the hydroxyl group can be in 2 or more positions, you have to add a number, just like we've already done with other molecules that we've named, alkyl halides, for example. So we have 1, 2, 3, 4 carbons. That makes it bute, right? We see that there's an alcohol group, so it's got to be an all, single bonds, butanol. And the OH group is on the number 1 carbon, so we add 1 dash butanol. If that's a little bit small, I'll rewrite that for you. That's 1 dash butanol. Okay, another isomer here would be 2-butanol, because the OH group is on the second carbon. Whether you capitalize this B or not, it doesn't really matter to me. But anyways, and I hope you remember from previous lessons that there cannot exist a 3 or a 4-butanol. We wouldn't name it that way, because if this OH group was on this carbon, it would be the same as this molecule, right? It's just flipped around. It's like looking at it from the other side. So it's not a different molecule, it's just a different perspective on the same one. And of course, you wouldn't have a 4-butanol because this is really the number 1 carbon, same as this. If a compound has more than 1 hydroxyl group, okay, so those examples have only been 1 OH group, then we have to use prefixes such as di, tri, and tetra. That makes sense, right? We did that with the halocarbons. And they are used right before the all. So it's not before the carbon chain name, but it's actually before the all. This is a bit different with the alcohols. So prefixes before the OL, okay, before the OL in the name. And that indicates the number of hydroxyl groups present. The full alkane name, including A and E at the end, is used before the prefix. So a few complicated rules here, but let me go over this example here with you. Okay, so in this compound we have 3 carbons. So we know that it's going to be meth, eth, prop, right? So propane, this is propane. There are 3 hydroxyl groups, 1 on each carbon. So we know that this tri, meaning 3, is going to have to be included in the name. Now with alcohols, the tri does not go at the beginning of the name, it goes before the OL. Where are these groups? We could have couple on 1 carbon, right? Or even 3 on 1 carbon. So that's not the case. So we need to name where these hydroxyl groups are. And of course, they're on the 1, the 2, and the 3. There's 1 on each. So that's why we name it 1, 2, 3. Remember, between numbers and words, we'll put dashes. Dash. 3 carbons. So it's propane, all with single bonds between them. Tri is the 3 hydroxyl groups. All is the ending for alcohol. So it's 1, 2, 3, propanatriol. Propanatriol, propanatriol. That's sort of how you name propanatriol. Okay? Now this that I stroked out here, this is the common name for this. Now aren't you glad that there are common names, everyday names for these? And you've probably heard of this. This is the compound for glycerol. Okay? This is glycerol. So there's the IUPAC names, and that's the proper naming that you will see in a lot of textbooks, but there are also the everyday sort of common names which you will also see. So, you know, there's a technical name and there's the everyday name. Just like, you know, in species, animals and that sort of thing. There's the technical name, then there's the common everyday name. Okay? Anybody have any questions? So properties of alcohol. You guys know some of the effects of alcohol. I've heard of many stories, tragically, of the effects of alcohol. But what are the properties of alcohol? What's the actual compounds? What are they really like? So hydroxyl groups of alcohol molecules are moderately polar. So they are slightly polar with the oxygen and the hydrogen. There's a big concentration of electrons in this CO bond, and so that leaves the H a little bit positive. So they're able to hydrogen bond with other hydroxyl groups, okay, giving them a high boiling point. So alcohols are moderately polar, giving them a high boiling point compared to hydrocarbons. Also, because of their polarity, they engage in hydrogen bonding, and that was mentioned up here as well. Also, because of their polarity and hydrogen bonding, ethanol is completely miscible with water. Now, miscible, from the freedictionary.com here, is capable of being mixed in all proportions. So, if something is, you may have heard the term immiscible, okay? That means that it doesn't mix well, okay? You can still see parts of each individual thing that are trying to be mixed, like oil and water. That is immiscible. They don't mix very well together because you can still see the individual parts. But something that is completely miscible means that it will mix very, very well in all proportions. Okay? Large scale, small scale, and usually with liquid. And actually, if we go back here to the note here, miscible is capable of mixing, and the example is alcohol is miscible with water. Okay, so that's capable of being mixed and so on. Okay? Relating to two or more substances such as water and alcohol, they can be mixed together in any proportion without separating. All right? Okay. Because of their polarity, alcohols are also good solvents. Okay, so miscible with water, good solvents. They can dissolve other polar organic molecules. Methanol is a common industrial solvent found in some paint strippers. 2-butanol is found in some stains and varnishes as well. So there are some properties of alcohols. Uses of alcohol, obviously ethanol is found in alcoholic beverages and medicinal products, and is useful as an effective antiseptic. Okay, so antiseptic, so to for cleansing and to help kill bacteria and stuff like that. And it's also a gasoline additive, as we mentioned at the pumps. You'll see, ethanol added. Denatured alcohol is found on the shelves of drugstores, so your hand cleansers and stuff like that. It's ethanol with small amounts of, and when you have these hand cleaners that smell like really, strong scents of this that's the alcohol you're smelling. It's mixed with some noxious materials so that people don't end up drinking it or consuming it. Some of these materials that they're mixed with this alcohol is aviation gasoline. So basically, gasoline is mixed in there a little bit. Some other organic solvents or like organic cleaners. And so that's basically noxious means to make your stomach sick, so it's not meant to be consumed. Cyclohexanol is a poisonous compound used as a solvent. So whenever you see cyclohexanol on a ingredients list, or on a bottle, you should see a poisonous Wemyss symbol there. It's used as a solvent for certain plastics and in the manufacturing of insecticides. So cyclohexanol. And glycerol, which we just took a look at, right? What was that again? Glycerol, the name for it was 1, 2, 3 propanotriol. Okay, you guys are all right. It's okay. Just always help me. Glycerol is often used in antifreeze and in airplane de-icing fluid. Take a few minutes here and copy these down and try your hand at naming these alcohols. See what you can do. Use all of the rules that we've been talking about so far, and see if you can give it a shot. A, we have 1, 2, 3, 4, 5 carbons, right, in an aromatic chain, so it's cyclopentanol. Cyclopentanol. are 1, 2, 3, 4, 5, 6. 6 carbons. Okay, so that's going to be hex and all, right? Okay, it's going to be at the end there. Now we have to name the hydroxyl groups, so we have one here and one here. Remember, we want to keep the numbers as low as possible. So this is going to be 1, and this is going to be 4. So what should it be? 1, comma, 4, dash, dash, dash. Now, do I put the die here? No, I don't. Because we put the die over before the all, right? So it's hexana die all. Okay, so 1, comma 4, dash hexana die all. Does that look right? Okay, here's the answer for C as well. 2 hydroxyl groups. They're on the 1 and the 4 carbon. And there's 2 identical ones, so 1, comma 4, dash hexana die for the 2 all. So go ahead and finish, get some practice doing those 2. And the last part of this lesson would be to draw these ones, and I'll throw an example up here in 1 second for you. The structure for 1,2-butadiol right here, and you can try your hand at the rest of these. So that's the rest of the assignment for today.